Hi, welcome to our webinar today, which is Building Performance Evaluation for Architects. I'd just like to say thank you for taking the time out of your morning to join us today. I just ask that if everyone can remain on mute throughout. There will be an opportunity for questions at the end. If you have anything in the meantime that you'd like to pop down in the chat box, you're very welcome. If we can deal with that as we go, we will do. If not, we will be addressing that at the end. So just to introduce myself, I'm Lucy Cowell and I'm the Client Relationship Manager here at Veritherm. So just to explain a little bit about Veritherm, first of all, we've been developing our technology for a number of years now to get us to the point where we are world leaders in building performance evaluation. We're best known for our innovative and unique thermal performance testing solution, which is a service that we're now able to offer throughout our network of delivery partners across the UK. We're delighted today to be joined by our guest speaker, who is Neil Young. He works on the BECCI project at the University of Wolverhampton. So I'll be handing over to him partway through and he'll be taking us through some case studies of buildings we've worked on together and how building performance evaluation was used on those. So just to do a quick overview of building performance evaluation. So rather than relying on theoretical assumptions about how a building is performing, it can mean gathering a variety of data to understand whether a building is performing as it was designed to do, or whether there is actually a performance gap. So it could be underperforming, it could even be overperforming compared to its design, but without the proper research and measurement, there's just no way of knowing. So there's often an assumption that BPE comes towards the end of the process, but actually it's really important to introduce it really early on. So even from the earliest concept and design stages. So you need to sort of get the client to commit to a soft landings approach at that point so that appropriate budget can be allocated for later on. So in order to do that, you would need to determine with the client what it is you're looking to achieve, what the aims are, who's going to be doing it, and what is actually to be monitored. So when it comes to the construction stage, BP is still going on. You need to be thinking about what things need to be actually built into the building, if there are inbuilt sensors that need to go in there. So it's still something that needs to be considered right the way throughout. Then moving on to the pre-occupancy stage, when you're actually commissioning systems. So rather than just commissioning them and assuming they work, they actually need to be assessed and tested to ensure they are actually working as they were designed to do. Then moving on to post-occupancy evaluation, the RIBA stage 7. Monitoring would continue after occupancy has happened. So throughout the defects period, that would be to identify any problems that there might be and ensure that things can be rectified. And then longer term, carrying on monitoring, ideally over one whole seasonal cycle to see how the building's performing in various conditions. That would focus on the operational performance with in-use data, taking into account how buildings are being used by the occupants and how they're affecting the results. So BPE can play a vital role in facilitating feedback between clients and designers, which could be in the form of client questionnaires to understand their user experience and satisfaction levels. It could be about analysing ventilation and maintenance strategies, or it could be actual measurements of things like the thermal comfort, acoustics, air tightness, heat loss and air quality. So it's really important to understand the value of BPE for the client. So it can be a particularly hard sell because the client might assume that they're getting the building that they were promised, and rightly so. But the BPE can actually give them extra confidence that it's performing as well as it should be. And if it's not, then that can be identified and allow fine-tuning to help the building perform to its optimum capabilities. And ultimately, it ensures that the project outcomes align with the client's needs. In terms of value to the architect, as standard practice, an architect can promise a building, deliver it and walk away. But actually there's so much more that can be done and learned from understanding where it is actually that, whether the building is actually the one that you designed. So by using real world measurements, you can understand whether those theoretical desk-based assumptions were correct and actually reduce the performance gap. So it's a continuous learning process for you. And it might be that mistakes are made along the way, but at least knowing about them aid your knowledge and understanding for future projects. It can also foster better and longer term relationships, which I think is a really important one, that the client knows that you're actually doing your best to meet their quite often complex needs. So in terms of understanding what the market drivers are for using BPE. There's a number of important things happening at the moment, which will mean that verification of performance will be so important in the future. So just looking at a few examples here, there's the green recovery, which was the government's commitment to support green jobs with a £12 billion investment. There's the British standard for building performance evaluation, which has been developed by the Building Performance Network. And that's using the criteria of best practice for building performance and data collection and analysis, providing peer review for the industry, and creating a platform for collaboration. There's the UKG BECCI playbook, which is where local authorities now require developers to demonstrate that they will act to close the performance gap. And probably the one I've left to the end is the one that's most important for us and top of our agenda is Annex D of the Future Home Standard, which places a lot more responsibility on the designer and developer to ensure that the predicted energy performance is actually being achieved. So when we understand all that, we wonder why the industry isn't actually doing this already, because it just makes such good sense. So there are some barriers that exist, which can make it quite challenging. So this can involve complex data, which can require specialists in their field or academics, which can ultimately prove really quite expensive. If data needs to be downloaded from USB sticks that are in situ, that can involve multiple site visits, which can be quite intrusive with arranging access, especially at the post-occupancy stage. So I'm just going to pause there for a moment and I'm going to hand over to Neil and he can give us some examples of how building performance evaluation has been used in some case studies.
Yeah, so my name's Neil Young. I work at the University of Wolverhampton in a group called the Built Environment Climate Innovations Group, and for you and me that means BECCI. I'm just going to have a quick chat with you and share some experiences, if you like, of diagnosing the energy performance gap in houses. And this is a project we work with Veritherm on, but we've done quite a lot of other work. So just going to take you through a bit of what I'm going to talk about. Quick rundown about what BECCI does. The kind of three main ways of assessing thermal performance. A little bit about what thermal imaging can do for you, and then run through some case studies, and then maybe, if you're interested, some opportunities to get your own buildings tested. Okay, so wrong way. So this is BECCI. We're focused on buildings. Our kind of main aim is to get new products into the market that save energy, and that's a kind of part funded by the EU and part funded by the university, and that's background to BECCI really. So what do? We support businesses with, things like market research reports, innovation strategies and that kind of business stuff. We do quite a lot of energy monitoring. We've done work with housing associations and businesses to do that kind of stuff. Interested in air tightness testing because, a leaky house can waste a third of your energy when the wind blows. Thermal imaging, I'm going to take you through a bit of that now. Energy audits, we work on occupant behavior. We've measured some housing association buildings and we understand where all the energy goes through all the circuits and while it's been occupied, and how much of the PV energy is used, and if you install a battery, how that kind of works. We do a bit of thermal fabric testing. We do various different simulation programs, quite a nice cheap way, if you like, to get products tested. We've done quite a bit of battery testing, as I mentioned earlier, and we're kind of finding that at the moment, the life of the battery and the payback is, not matched at the moment, but things are changing fast. Okay, just going to take you through the fabric performance, and as with all universities, we need to know what the evidence is. There's lots and lots of studies about this. I've just chosen one from Napier University because it's got a nice visual graph, if you like. So this is a study of 33 houses, and the predicted energy use, heating energy use, is these orange graphs here. And so the predicted mean for those is this dotted line there, and then the houses were lived in, if you like, the buildings were used, and then this was their energy performance in blue. And so the mean of that is this dotted line here. And these were, you know, way better than the standard Scottish averages, if you like. But nevertheless, the predicted mean was 4,000 kilowatt hours per year, and actually measured at 8,000. So we can see they're using twice as much energy as the prediction, and that is what the energy performance gap is. These predictions made by SAP or RD-SAP, and we can kind of see here that the fabric is key to managing the heating demand, and so that's, you know, why I'm interested in this topic. So what methods are there to measure it? We've got the co-heating test, which is kind of the gold standard. It takes 2 to 3 weeks to do. What you do is you heat up the building, you put your sensors inside, you're measuring the outside temperatures, environmental conditions, if you like. You're taking loads of measurements, and you're then doing some calculations and working out the fabric performance. So that's got to be done when there's no one in the building. And if it's new build, then you're thinking, well, okay, that's got to be kind of handover. So now you're waiting, you're making the occupant wait, and you're presumably not handing over for money when it should go across, so you're delaying all that 2 or 3 weeks. And so that's probably a good, you know, the reasons why that's not really taken off in any way. So Loughborough University and others have said, well, okay, what happens if we can do that while the building's occupied? Maybe that's a way that you know, you can get it widespread use of a performance measurement system. And you know, so essentially what they're doing is monitoring all the energy, which is what I talked about before, and understanding where it's all going and coming up with a number. But then when you look carefully at this way of doing it, you're going, okay, you look at your building and it doesn't perform. So now you've got people in the building, and you're saying to them, you know what, your building doesn't actually meet what it's supposed to do. What we need to do is get in here and pull that wall apart, or whatever. You know, so that's kind of another difficult conversation to have. What we really need is a short, fast test, and that's where I think Veritherm comes in. I'm hoping that we're going to hear all about it later on in the presentation. But it's essentially, it's an overnight test. You put your heaters in there, you know, rather the same as the co-heating test. It's got some clever maths, and puts all its data online, and in the morning, you know, arrived on your desk by email is the answer. So, you know, kind of, for me, that's a kind of a doable thing, and could be done on every house, and I think perhaps should be, but that's just my opinion. Okay, yeah, so that's the certificate landing on your desk. So, but what could go wrong? So you've done your test, and you found out maybe that you know, some of the things aren't as they should be. What kind of things could they be, or you know, what have we seen? First of all, the software model, you know, is that correct? Are there mistakes in there? Are there assumptions that have been made about the building, or you know, the site, or whatever, that don't turn out to be the same? You know, does SAP take everything into account? It's kind of a simplified method, and it is essentially, if you wanted to, you could put it all together on a spreadsheet, but obviously software does this in the main. And then you build your building, and you know, is the building built as the SAP data was put in? It should be, because you're supposed to submit a final SAP, but then there's no kind of process that ensures that the guy who does the SAP, or the person who does the SAP, actually verifies anything that he's told at the end of the project. So, you know, I worry a little bit about that. Is the occupant behavior considered fully? Well, definitely in SAP it isn't, because none of the plug loads are in there for a start. What about material substitution? You know, build time. Oh, you know, plasterboard's not available, so we did this, or you know, that material's cheaper, so we put that in. No one's going to know. I mean, I've been to some buildings where there's whole chunks of, insulation completely missing in the wall, you know, because no one can tell, no one will know that. I would just leave it out, you know, that kind of stuff can go on. You know, is the build quality at a level that the design was done for, you know, and how can we tell? So that's kind of what I'm talking to you about now. So so is thermal imaging the answer? Thermal imaging sounds great, but there's a bit more to thermal imaging than meets the eye, and I'm just going to quickly take you through some of the things that that you perhaps need to know when you're doing thermal imaging. So the camera sees radiation, it doesn't see temperatures. I know it's got temperatures on the screen, but it doesn't actually measure temperature, it sees radiation. But temperature and radiation are connected by mathematical laws, and the camera calculates the temperature, and it has various inputs that it needs to calculate that temperature. And if you don't put them in correctly, you're going to get the wrong number on the screen. Not that that really matters in some instances when you're just comparing this wall to that wall or whatever, but if you're going to do from this day to the next day, that kind of thing, then you know, then you need to kind of set it up properly. Okay, some examples of that, I'm not going to go through too many. The emissivity, the surface emissivity. I'm just going to show you what that is. So there's my mug sitting on the bench at work, and there's a bit of black tape stuck on it. So we can see, you can imagine that that tape is the same temperature as the mug, or very nearly. We take a thermal image of it, and what do we see? We see that the tape here looks as though it's hotter than the mug, and we know it isn't. So what's happening there is the tape, because it's black, is emitting differently to the white porcelain, if you like. And so I'm just kind of saying that, you know, you've got to watch out for emissivities, and, you know, say aluminium or something shiny is, you know, 5-10 times more emissive and reflective than you know, than a brick, say. So reflections, reflected temperature, how does that work? We put something shiny next to it, and then we pick the camera up, and we see that this would appear to be a higher temperature immediately. You know, we know it can't be. So what's going on there? So the radiation is coming from the mug, hitting that aluminium and bouncing back and reflecting. So reflections are kind of need to be taken into account. There's lots and lots of theoretical stuff about thermal imaging, which I'm not going to go into today. I want you to just have a look at radiation. What is radiation? Well, it's the process of heat transfer between two bodies, if you like, emitting and absorbing these electromagnetic waves. So the camera images that radiated energy in the thermal spectrum. It's not in the visual spectrum. We know that. This is some guy warming up his hands on the fire. You can't see any kind of radiation, but you know that that's kind of warming, so it's non-visual radiation. Quick look at the radiation spectrum. Goes from gamma rays, X-rays, UV, and then we've got this little visible bit that we can see, but there's, you know, the radiation spectrum is huge. The camera is looking at this spectrum here, but it's not imaging that bit there. And there's a good reason for that. And that's because as the radiation goes through the air, it gets absorbed by various different components in the air. We can see that water really absorbs this section here. So if you didn't kind of exclude that from your camera, you'd have a water sensor in effect. So that's why that's kind of excluded. And so humidity is a part of the setup of the camera. Most people don't set up the camera accurately, if you like, but these are the settings that you really need to think about. How far away are you from the image thing that you're trying to image? Then we've got the background temperature, humidity, and that's the kind of reflected energy, and then the emissivity of the material itself, material surface. So the temperature measurements, these should be set up for every image. distance from the target, ambient temperature, relative humidity, which we've talked about, emissivity, which we've talked about, and reflective temperature. Essentially, if you're outside, the kind of reflected temperature of the sky on a cold winter's night is nothing, because it's all going in one direction, one way. There's nothing coming back, and so that that can register minus goodness knows how much, as much as your camera can image, really. But then inside, where all the temperatures 20 degrees C, the reflected temperature's about 20. Okay, so just showing you that. Examples of these settings, just quickly. So that's a auto-ranging image of a building in the university. Our office is in the bottom there somewhere. And we can see it's between 6.5 and 25. All the colored pixels are set between that range, if you like, so you get the maximum resolution. And this spot is 10.4 degrees C. So what's going on there? Same image, same night, minutes apart, but now this image looks as though it's just wasting loads of energy. It's just pouring out of there. It's way worse than this, but we know it isn't because it's only 10 minutes apart. So what's going on there? Well, what we've done is we said, okay, instead of going to 25, we're going to put all the pixels between 18 and 6.5. And the camera's going, hang on a minute, this is about 9.8 degrees C. We know it's 10.4. So the camera's kind of just alerting you that that something's not quite as it should be, and so that's because of the locked range. And then this one here, another setting that's not right or different. So here we've set the emissivity to 0.26, so something shiny. And now the temperature's recorded at -25, but the camera's going, hang on a minute, are you sure about that? And we can see this temperature's gone down to -40. So we can see that's kind of incorrect setting. So just wanted to kind of alert you to these things about infrared imaging. It's not empirical, it's kind of visual indication of comparison, if you like. Okay. Take you through these case studies. There's 3 case studies, 3 different types of building. So Sutton Lake, ICF building technology. So there's the insulation on both sides, and essentially you pour the concrete into the middle of it, and you get a nice airtight structure. So that's the building almost finished, and that's the other side of it, just to give you an indication of building. It's a big building, which we'll see in a minute. So the house was heated to 20 degrees C the day before. This was part of the Veritherm test as well. We did it that night. So the image was taken early on a day in March, cool day in March, and I say cool so we can get a temperature difference between inside and outside. Usually that should be 10 degrees C, but it was actually about 7, some number greater than 7, between 7 and 8. And we need that temperature difference so we can see the energy flowing. So the thermal images on the sunny side, happened to be a sunny day when we got there. We can't use those because obviously the sun has heated the wall up and disrupted that nice constant energy flow that we're looking for. We used a fancy £30,000 camera, basically, that's what it says. So we did the Veritherm test and we got the answers. And we can see that the envelope area is 660 meters squared. So just to give you a kind of a range, if you like, a typical housing association building, 2-bedroom house is kind of 200, so that's kind of 3 times the size. It's quite a nice big building. Its predicted energy performance was 240 watts Kelvin. So that's, if you imagine the house, it's emitting 240 watts out into the atmosphere if there was kind of 1 degree C difference between inside and outside, so per Kelvin, and in this case we've got 7, so it's 240 times 7 that it's predicted to emit. And when you do the measurements, you find that it's 534 watts Kelvin, so more than twice the it's using more than twice what it's predicted to do. But still the property is pretty insulated. So if you divide this number by the floor area, you can see that it's comparable to, you know, it's a good level, if you like, but still performing 123%, you know, less well than it should. So that's the energy performance gap, 123%. So we took the thermal camera out and tried to understand why that was. So skip that bit. So essentially, this test is you know, -11 to +13%. So that's pretty good. We're measuring 123% energy performance gap, and you know, to an accuracy of around about 10%, just over 10%. These percentages will change because of the conditions of under which the test was done. Okay, so oops. Yeah, so get the thermal camera out. Let's see what's going on. So we can see that the remember, this is an ICF, so we've got insulation this side, insulation that side, and concrete in the middle. So here we can see nice warm colors here, and the cold color is blue or black. So we can see the energy flowing around there and into the concrete as a bit of an energy leak. And you know, there's absolutely loads of pictures that were taken. I'm just picking some out, you know, typical faults. And as we go through the presentation, I'm just going to try and pick out different faults. So here we can see energy leaks here. Not quite sure what that is. Didn't go to the extent of looking at the drawings, etc. But this looks like some kind of structure here, maybe sitting on something there, or maybe the insulation's just missing there, or don't know. But definitely faults there. This is another big one. So on every entrance and exit out of the building, you know, this is kind of a break through that ICF. So insulation here, insulation there, but no insulation on the top there. You know, so again, it's just the same as that one. The heat is just flowing down there into the concrete, and well, more or less lost to the house. So this is an interesting one. So there was a wall across here, and during the build, it was decided to make that wall another meter further on, and this orange spot here is the same as that one there. So essentially, they, you know, concrete taken out, but not taken out in this bit here, or penetrates through the insulation. This is a worry for me in a way, because, you know, if the humidity for some reason is high-ish in this building, and the temperature goes down at night, you know, we might get some kind of condensation on that area there. So that's a bit of a worry if humidity levels in the building are higher in use. Okay. Oops, not again. Sutton Lake, that's another case study. Oh, sorry, continuing on that one, sorry, outside. So we've got in this bedroom up here, some kind of thermal bridge going on up there. This loft hatch, by now the sun has heated up the loft and it's just pouring through there. That really looks completely uninsulated. So you can imagine at night that's going to go cold and the heat's going to flow the other way. These light fittings, they're not airtight and they just leak heat either way. So if you put them in the loft, this is the kind of thing that's going to happen. Bit of a summary: lintel design, floor threshold design, late stage design changes, insulation mistakes possibly, and your choice of fittings in the building. So that's the end of the first case study. Get it right this time, yeah. So Maisie Finn near Oswestry, nice building. I'm going to refer to this wall here, great big window wall there later on. Just remember that. It's a timber frame building. It's at a passive house specification. It's not passive house accredited, so the process wasn't necessarily followed. That cost money, and it's not primary built for sale. So that means that you know, the fittings and the windows, etc., were, you know, fantastic quality. So what happened here? We've got 452 meters squared floor area, so that's kind of twice the typical 2-bed house, if you like. Reasonable size. predicted mean at 85, which is really low, and we can see that here. You know, it's at a good quality, if you like. So the energy flows that you're going to see here are much lower, but the thermal camera can't tell. It can just show you the differences. So it might look absolutely terrible, but I'm just pointing this out to you now. The flows are a lot lower than the other building. But again, the actual energy performance that was measured is still way higher, 57% energy performance gap than the predicted. Why is that? But again, the accuracy, if you like, is a lot better now. It's, you know, up to 10 rather than just over 10. Again, the conditions that the measurements were taken under. So let's have a look at the thermal images on this one. So here we can see what looks like a huge thermal leak here, but again, you know, it's lower amounts of energy, but the camera can't tell you that. Essentially, the energy is coming down through the floor here and under there, because this insulation doesn't go all the way down there. And there must be an energy path there through something that's not quite as insulated. This one here, again, we can see that the floor insulation probably comes up under the wall there, and it's not as thick. So we can see that there's a kind of an energy flow down under there. So these windows were really high spec, triple glazed, fancy quality windows fitted by the manufacturer's installer, but we can still see these little leaks of energy through various different places. Probably not much, but nevertheless interesting. Here I think we can see the energy flowing around the frame here. Probably not much, but nevertheless, if we're looking for differences, there's one there. Yeah, so continuing on, I've seen this a lot in this type of window. Don't quite understand what is going on behind here, but some kind of energy leak through there. Bit of a worry there for condensation, really. Difficult to know because we're not actually measuring the temperatures. Here, again, some kind of very slight energy leaks around the edges of that door there. This is that great long window that I talked about. There's a beam that goes all the way across the back of the house there. It doesn't look like a really bad energy leak, but there's definitely one there. And this is the reflected temperature. I didn't go and stick my face on that window there and then go and take a picture of it. That's just the reflection. Just a practical example. Poor image taking by me, I guess. Bit of a summary. So the wall floor junctions, the patio door lintel, window frames and door frames around the edges here. I did see some leaks through the closing seals. I see it a lot where the seals on the door at the corners are welded. It's a bit harder, and so nearly always there's a bit of a leak there, particularly if you look at the air tightness way of doing it, which I'm not going to go into. But yeah, last case study, Lindsay Mill Gardens. So this is kind of a couple of images of it. Technology, block and brick, higher specification than building regs. It's built by a developer for sale. Slightly different drivers in the build. How did it come out? Here it's really gone. Yeah, predicted at 70 watts per Kelvin, 70 watts coming out of the building per degree C of temperature difference, if you remember. How did it come out? Well, it came out at 101, so giving an energy performance gap of 45%. So let's have a look at why that might be with the thermal images. So different drivers here. The quality of the windows maybe not quite as high as the passive house version. Here we can see a bit of energy coming out through the seals, under the seals. None of this has been forced out by a blower door fan. These are just images taken. It might have been a lot clearer if we put a fan blower in the door and just kind of pumped up the house a little bit and watched the energy coming out. But we didn't do that. Here, there's quite a lot going on at the top of the wall where the roof joins, the roof wall joint. You'll see it in lots of different places. But this looks like the insulation is just not folded down or not missing or not long enough or whatever reason it is. And again, there's something going on right on the top of the wall there. Different location. Looks like these structures are, causing some kind of thermal bridge there. Bit around the windows here, I've noticed. Normally you can tell there's a fault when it's not consistent. If it's kind of consistent color all the way along, then maybe that's how it's supposed to be. But if there's a kind of a dark bit in the middle, you're going, I wonder why that is. Yeah, so a few faults there. Continuing on, cold air in the loft this time coming out. And again, if I put a blower door and sucked a bit of the air out of the building and let it come in through the leaks, we'd see lots and lots of leaks here. This one's a bit odd. So right in the middle of that wall there on the stairs, there's a kind of quite a bad leak through the wall there. Why that would be, don't really know. So this light pipe here, the insulation around that, I don't know whether that was fitted later and the insulation was pulled up and not put down correctly. And again, we can see this, there's something going on at the top of the wall here. Bit of a summary. So thermal bridges through the door frames and etc. Insulation faults, plenty of those. There's something going on at the wall ceiling junction, leaks through the loft hatches, and this one here, hesitant to kind of say out loud, but essentially when you look at the outside, you can see something going on here, maybe energy going into the cavity and then finding its way up here. But I'm not saying that out loud because don't understand what that might be. Okay, so that's it really. If you live in Shropshire and the Marches, call me about a free Veritherm test if you're interested in understanding this and interested in saving energy. Okay, so that's me done, Lucy.
Thank you very much for that, Neil. I think what was really interesting there as well was looking at the sort of highest performing houses and the passive houses and just seeing that although they are still performing really well, they're still not actually performing as they were supposed to be and what was predicted in PHPP. So I think it's just a really good example of if you didn't do the measuring and testing afterwards and the monitoring, you'd have no way of knowing and be continuing to design things that you're assuming are being performed to a certain level, and actually they're not. So I'll just move on now to explaining a bit about the Veritherm test and understand why it's different from other testing. So the Veritherm test, our unique selling points really are that it is fast. It's carried out overnight in an unoccupied building. It takes 12 hours or less. So it's from the hours of sunset to sunrise. It's scalable. So the results are instant, immediate. As soon as the test is completed, you get a PDF showing you the certificate that Neil showed, and also a longer form report as well, giving you greater information about the data plots around the building. It's also very simple to use. We've trained up delivery partners across the UK. These are people that are already doing testing, so they might be doing airtightness, acoustics testing. So they're adding this into their existing services. So they're not specialists by any means in thermography necessarily, because all the specialist technical knowledge has already been developed by our technical partners. So that's all built into our cloud-based platform. So they don't need to do any of that work themselves. It's also cost effective because it only takes one night, as opposed to the co-heating test, which can be thousands of pounds and out of the reach of most people. This is very cost effective, and it's only from £500 plus VAT for a small dwelling, so a small to medium sized building of 2 to 3 bedrooms. So just looking at how the Veritherm test actually works. So just on the right here, you'll see a building and how we set it up. So first of all, we'd have a preparation stage. And this is where we would speak to the clients and designers and obtain data from the SAP worksheets. The reason we do this is so that we can compare our results against the predicted design. So that information is entered onto our cloud-based platform. The engineer will locate the equipment on the site to ensure there's an even mix of heat throughout the building. So there'll be the temperature loggers, the fans and heaters. So the fans will circulate the heat to give that even spread throughout the building. There's also temperature loggers outside the building, which monitor the external temperature. So we can differentiate when the heat is lost through the building. At this point, the engineer is able to leave the building and we move on to the measurement stage. So as I said, the test is carried out overnight between sunset and sunrise. Our platform has already predetermined the time that will start. Using the smart system and the smart plugs, when that time approaches, that will actually activate the system and activate the test. So the test runs throughout the night. During the first period, the heating takes place and measurements are constantly being sent back to the cloud-based platform throughout that period. And also then for the second phase of the night, when the heating's switched off and the building's left to passively cool, and measurements are still taken continuously throughout that period. And again, because live data is being streamed to the platform, that can be viewed remotely in real time if you wish to do so. At the end of the test, the platform will produce the result immediately. So you get the copy of that certificate that Neil was showing you, and you'll also get a longer form of the report, which will give you more information about the individual data plots. And that's when you can decide what you want to do with it. So depending on why you were doing the test in the first place, will help you decide what you want to do with that information from there. And it can be shared across your design team and with your clients. So we've been working with a lot of clients across the industry. So I'll just share a few testimonials with you about what people have said and what they've thought of the process. So one homeowner we worked with said, "The Veritherm process gives me incredible insight into the leakiness of my house and blew away the traditional calculations fiction. As a result, I'm in a much better position to design a low carbon heating system that works for my home." With the director of environmental consultancy, they said, "What we really like from the Veritherm test is the speed. A next day result gives instant feedback. What's more, we can use it as we go to drive QA and right first time delivery." And an architect we work with also said that the Veritherm test gives the building a voice, helping us to hear what is required and better understand its needs. So for retrofit, it's hard to see why you would test any other way. There are many different scenarios when you would use when you could use a Veritherm test. So they might be used by housing associations, developers, product manufacturers, amongst others. But we'll just look at two of sort of the more common examples as well, which is the new builds and retrofits. So we like to use the sort of who, what, why, and when we think about Veritherm testing. So what's being measured is for energy demand, fuel bills, internal conditions. So we need to know those things because we want to gauge the level of performance that's being delivered. We want to check the quality of workmanship, and we want to also predict any future issues that might arise. So there's various stages when you might want to use a test. It's not necessarily just at the end on completion. So it could be a self-builder that's heavily invested in the project. They're taking a very keen interest and wanting to make sure they're getting the best for their money. And they want to understand if it's not performing as well as it should be and sort out issues before they arise or develop. So it could be that they would do that before internal linings go in so that things can be amended without causing disruption. It could be on completion for the reasons we've already mentioned, or it might be later on if they're already experiencing issues with the building and they want to understand why. It also might be reason for doing it is because the architect's trying out something new and they want to understand, actually, is that working, is it not working, and just aid their future learning. So retrofit is a very big market for us, and particularly in retrofit, it can be used at multiple stages. So before work even starts, it's a good time to use it to just establish a baseline measurement of understanding actually what you're dealing with. And from that point, you can develop a strategy from there. So you can also continue to test at different stages to see the differences the individual changes are making. So it might be you add in more insulation and then test again afterwards and then just see if that was actually working as well as you'd hoped. It can also be used to understand the heating requirement of the building and therefore help determine the size of the heating system required so that it's not being under or over specified, but is actually meeting the requirements of the occupants and the building. A Veritherm test can actually be carried out alongside other tests to give a full building health check. As I mentioned, our delivery partners are people that are already trained up in various other testing or performance testing of buildings. So we are able to offer packages now. So as well as just having a Veritherm test on your own, we could offer you a package where we incorporate air tightness testing, thermographic surveys, or sound insulation as well, to give you sort of a really good complete health check of a building. And doing that all together with one engineer on site is less intrusive for clients. It's cost effective and a convenient way of evaluating the building's performance. So from an architect or client's point of view, the whole process is really very simple. You can give us a call or one of our delivery partners a call and just speak to an advisor and explain your project, and we can help you and decide which package might be best for you. We'll be able to confirm a date with you, and from that point we'll then ask you or the client for the design information that we can upload to our system ahead of time. The engineer will be deployed on the day. We'll set up the test, and then, as I said, immediately at the end of the test results are produced and can be shared amongst the design team and clients for you to decide what you want to do with those and your next steps moving forward. As I mentioned, we have a number of delivery partners now. We provide training to them, and so just so you can see, we've got a really good coverage of the UK. So pretty much everywhere in the UK, we've got testers that can go and do those tests now. So although we're best known for our thermal performance testing service, we're actually continuing to evolve at Veritherm, and we're expanding the services we're offering. So something we're currently working on is Veritherm monitoring, which is where we're going to be deploying in-use monitoring systems. So as well as heat loss, we'll also be able to identify things like risks of condensation and mould, air quality, overheating, and the things that generally affect the thermal comfort for occupants. So what's great about this is that we're going to incorporate it into our existing platform so that we can continue monitoring the data in real time. So rather than having USB sticks that you have to go in and collect the data, it'll just be uploaded and it can be viewed remotely if required. So that's something that hopefully by the end of this year we'll be able to bring to the market and offer out. Also towards the end of this year, we're going to be offering Veritherm Industrial. This is very similar to the domestic setup, so it works in the same way. It's just we'll be using scaled up versions of the heaters and the fans. This is great because industrial units are very large energy consumers, running 365 days a year. So there are massive savings to be had by getting the thermal efficiency improved and as good as it could be. So the service we'll be offering with this one will include the Veritherm test, alongside the level 2 air tightness test, and also a visual inspection of the thermal envelope using drone thermographic equipment. And to sort of summarise really, all these things will be about applying the learning and helping to improve for future projects, whether that's for the industrial, the domestic, or with the monitoring as well. So that brings me to an end of my presentation. So at this point, I'd just like to open up and see if there are any questions. So I've got myself, Neil, and also our founder and managing director, Tom Fenton, is on the call as well. So if there's any questions for any of us, then yeah, please unmute yourself and let us know. Thank you.
Yeah, thank you very much for that, Lucy and Neil. As Lucy said, it would be great if you guys could ask any questions. So whether that's via the chat function, or if you'd like to now unmute yourselves, I've just done that using the unmute request. So if anyone would like to ask any questions, you should be able to unmute yourself.
Hi, I don't know if you can hear me.
Yes, yeah, we can hear you.
Thank you very much, and very, very interesting. We are a housing association, and you know, obviously for all the reasons you've stated, very interested in what this service can offer. I'm kind of new to thermography really, but the limited knowledge I have is the conditions you need for a proper survey very much are dictated by weather conditions. So if it's been raining, or if it's in a summer's day and the temperature difference isn't as high or wide as it needs to be, are there limitations to when you can carry out a survey, and therefore does it limit the effectiveness in what you hope for?
Hi there. Yes, so there are some limitations, although our testing system has been validated in a number of weather conditions. So as long as there aren't extreme gales or heavy snow or driving rain, it's fine to do. Our platform does sort of give an indication of weather a week or so in advance, and will give you warnings if it thinks it's not going to be suitable for any of those reasons. Also, like you mentioned with the hot weather, that is an important one. So things like June, July, August is a quiet season where we wouldn't recommend carrying out tests if the weather's going to be extremely hot temperatures, because we do need to get that temperature differential between the outside and inside. So, so there are some limitations, but largely for most of the weather conditions that the UK can throw at us, the Veritherm system will work well.
Yes.
And it kind of goes hand in hand as well with thermography and Veritherm. You tend to need the same types of conditions to conduct a survey. Usually around a 10-degree temperature difference is the limit of conducting a viable test and result, really. I think, Neil, would you agree with that?
Yeah, so thermography would be, you know, we don't do thermography at night, basically, is what I'm saying. So thermography would be less useful, if you like, because you're going to go in the day, you're going to want to take visual and thermographic images, and the Veritherm test is, you know, done at night on its own. There's nobody there, you know. So I kind of, in my mind, I'm thinking the Veritherm test is a bit more flexible than the thermography.
Yeah. I'm sorry to hog. I'm a great supporter, so please don't take it as a negative. But as a social landlord undertaking retrofit of a large portfolio, are we having to move all our residents out for one night to undertake these tests?
If I could take that one, Lucy. So what we tend to do, certainly with social housing and housing associations, is we tend to test things like void properties to identify strategy. So, you know, establishing baseline measurements and then testing throughout a whole house retrofit, and then using it as a Q&A tool on a sample basis thereafter. But also, as Lucy suggested at the end, we now have the monitoring tool, so that can then be used post-occupancy or for occupied dwellings to kind of gather data on heat loss for the remaining homes that can't be accessed. So I think as we progress further, you know, we have lots of different applications for lots of different use cases. And certainly for the retrofit market, I would suggest starting with a Veritherm test to identify that your strategy is right before you commit to, you know, upgrading 20,000 homes, for example, and then actually implementing monitoring thereafter to kind of fill the gaps and gather all of that data kind of long term. So I think that's a good place to start, probably.
Thank you. Thank you very much.
My name is Rafty from Lindsay Architects. Just a quick question. Most of the presentation focused on the post-occupancy evaluation. I'm just wondering what sort of mechanisms are in place to sort of test throughout the construction phase and pick some of these things up early.
Tom, you okay to take that? I couldn't quite catch the end of that one.
Yeah, thanks for that, Ralph. Certainly what we've done in the past on some projects is phase testing. So a bit like you'd see with air tightness on a passive type project, you can actually implement testing at various stages of the project so that, you know, issues or gaps in performance can be picked up and rectified before, you know, the building is finished. So that might include testing once insulation in but internal linings aren't installed, so that ultimately you can identify areas of weakness in the building fabric before they're enclosed. So what we say is Veritherm isn't just a handover test. It can be implemented early in the project and post-completion. So I wouldn't limit the solution to just a pre-handover assessment, because ultimately you want to give yourself the best chance of actually rectifying and minimizing the gap in performance before it's handed over to the occupant, really.
Excellent. Yeah, so effectively what we could do is just at the start of the project, once you kind of agreed the outcomes, you sort of develop an appropriate strategy together with you and kind of identify the key test points to ensure that you sort of pick up whether you are heading in the right direction, and kind of minimize any performance gaps when it comes to handover.
Yeah, and I think that's the great thing with Veritherm is it can be applied quickly at lots of different points, so you can get that data and respond to it and make informed decisions. So that's for a new build project or for a retrofit project, really. So yeah, I think if that's something that you're looking to do, then certainly engage with us at an early stage, and like you say, we can then look at a strategy for implementation of testing, you know, throughout the project and post completion.
Brilliant. Thank you.
Thank you.
Okay, so if you don't have any other questions, I'll just end with our contact details there on the screen. If you do have anything you want to discuss later on about what it takes or what you need to become a Veritherm tester, or any projects you have in mind that you might want to discuss, then please do just get in contact with us on those details on the screen. So just like to say thank you very much to Neil and you all for attending, and I hope you enjoyed the presentation. Thank you.